Section 6.6 is about systems of inequalities. So we're going to be doing systems of equations just like before, but instead of equal signs, we're going to have less than or equal to, greater than, or greater than equal to signs in our problem. So here's an example. It says, solve the system of inequalities. Y is less than 3x, and y is greater than or equal to negative 2x plus 1. So if you think back to when we graphed inequalities before, this is where all this shading came into. So for the first problem, you always want to get y by itself first. And we know that y is already by itself in these problems. So I have y is less than 3x. So with y is less than 3x, I'm first going to identify that the slope is 3 over 1. And the y-intercept is 0. Since it's less than, I'm going to graph the line and shade below it. And since it's not equal to, I'm going to do a dashed line. So again, I'm going to start at 0. Then I'm going to go up 3 and over 1. And then I'll connect those points with the dashed line, since again, it's not equal to. And again, since it was less than, I'm going to shade below it. So below the line would be down here. Then I'll move on to the next equation. Y is greater than or equal to negative 2x plus 1. The y is already by itself, so I'm going to identify the slope as negative 2 over 1, and the y-intercept is 1. As always, I'll start with the y-intercept first, and then starting from that point, I'm going to go down 2 and over 1. And this time, since it's equal to, I'll do a solid line through those 2 points. And again with the shading, I'm going to shade above it since it was greater than. So where our answer is where the 2 shaded areas intersect. So it would be all of this area in here. I like to draw it in a little bit darker just so it really drives home the fact that this is the area that we're looking for. And what this actually means is if I pick out any point in this double shaded area and plug it in for the x and the y into both inequalities, it'll make both of them true. So here's another example, but this time we have 3 inequalities. So we're going to do it exactly the same way. We're just going to graph all 3 inequalities on the same graph, and we're going to be looking for the triple shaded area this time. And in that triple shaded area, any ordered pair from, again, that triple shaded area, when you plug those coordinates back in for x and y into all 3 inequalities, it'll make all 3 inequalities true. So let's start with the y is greater than or equal to 0. Since I'm missing the x, this would be a Hoy problem. So it's going to be a horizontal line going through y equals 0. It's going to be a solid line because it's equal to, and I'm going to shade above it. So here's my line going through where y equals 0, so it really ends up just being the x-axis, and again it's a solid line because it was equal to, and I'm going to shade above it since it was y is greater than or equal to 0. Next I have x is greater than negative 3. This would be a Vux problem since I only have an x in my equation, so it's going to be a vertical line through x equals 3, but this time it's going to be a dashed line since it's not equal to, and I'm going to shade to the right of it because numbers that are greater than negative 3 would be to the right of negative 3. So again, a dashed line going through x equals negative 3, and I'm going to shade to the right of it. So you can see here, this is my dashed line, and again, numbers that are greater than negative 3 would be to the right of negative 3, so I'm going to shade this way, designating that area for my shaded areas. Next, let's take our 2x plus 3y is less than or equal to 6 and get y by itself. So the first thing I would do is subtract the 2x. So I have 3y is less than or equal to negative 2x plus 6. Then I would divide both sides by 3. So I would end up with, I'm not dividing by a negative, so I'm not going to flip the sign, y is less than or equal to negative 2/3 x plus 2. I had to take both numbers divided by the 3. So I have a slope of negative 2/3, so down 2 and to the right 3, starting at the y-intercept of 2. I'm going to graph this one in red so you can see it better. So again, I'm going to start at the 2 and then go down 2 and over 3. So I started here at the y equals 2, and I'm going to go down 2 and to the right 3 and put another dot. This was equal to, so when I draw my line through this, I want to do a solid line since you do a solid line when it's equal to and a dashed line when it's not equal to. And then it says less than, so I'm going to shade below it. So now when I look for my triple shaded area, that would be this area in here where all three lines intersected. I had the ones above the y is greater than 0, the ones to the right of x is -3, and then now I shaded below for the 2x plus 3y is less than or equal to 6. So it's this area right in here where all three shaded areas would intersect. So that means that any point inside of that triple shaded area, when I plug it back in for the x and y's into my original inequalities, it would make all three true. So example number 3 says, write a system of inequalities for the shaded region. So if we look at part A, we need to find a system of inequalities to represent that shaded area right here. So let's start with this dashed line. It's a horizontal line, so I know it's going to have just a y in it and not an x. Since it's dashed, I know it's not equal to, and it was shaded below it, so it's going to be less than. It goes through the y-axis at 2, so I would get y is less than 2. For the other line, it's solid, so I know it's going to be equal to, and since it's diagonal, I know it's going to have a slope and a y-intercept. So it goes through the y-axis at 3, so we have a b value of 3, and then I can find the slope by counting down and over until I come to another point. So again, I'm going down 1, 2, 3, 4, and over 2. So down 4 and over 2 would be a slope of -4 divided by 2, which is just -2. So my slope is -2, my y-intercept is 3. Again, I would have an equal to since it was solid, and for this shaded area, that meant that it was shaded above it. So I would end up with y is greater than or equal to, again, greater since it was shaded above it, and equal to because it was a solid line. So y is greater than or equal to -2x plus 3. So my system of inequalities would be these two inequalities put together. Moving on to part B. So this time, I need to find a system of inequalities to represent this green area. So let's start with this vertical line. Since it's vertical, I know it's just going to have an x in it and not a y. So it would be it's shaded to the left, so it's going to be less than, and it is solid, so it's going to be equal to. So x is less than or equal to. It goes through the x-axis at 3, so x is less than or equal to 3. And then we'll look at our diagonal line. Again, we'll find the m and the b since it's diagonal. It goes through the y-axis at -1, so the b value is -1. And then we'll start at that point and count up and over to find the slope. So again, we're going up 1, 2, and over 1, 2, 3. So the slope would be 2/3. And as you can see, it would have been shaded above it, so it's going to be greater than, but it was a dashed line, so it's not equal to. So we would have y is greater than 2/3 x minus 1. So this system of inequalities would work for that green shaded area right here. And finally, example number 4. A logo contest requires that the logo width be between 3 and 5 inches, the height no less than 2 inches, and the sum of the width and the height no more than 9 inches. For part A, it says write a system of inequalities that describes the information given above. So since we're going to end up graphing it, I'm actually going to use x and y as my variables. So let's let x be the width and y be the height. So the first part says that the width needs to be between 3 and 5. So that means that the width, x, would have to be greater than or equal to 3, but at the same time, less than or equal to 5 since it has to be between those two. It can be those two, so that's why we have equal to. The next part says that the height is no less than 2 inches. So if it's no less than 2 inches, that would mean that it could be 2 inches or more. So the height, which is y, would be greater than or equal to 2. And then finally it says the sum, which means I'm going to add them together, of the width and the height is no more than 9. So for this one, I would take x plus y, and since it is no more than 9, that means it's 9 or less, so less than or equal to 9. So those are going to be my 4 inequalities that I'm going to graph all in one spot for part B. But first, remember, I'd have to get y by itself. So for our 4th inequality, let's subtract that x over. So it would be y is less than or equal to -x plus 9. Remember there, and of course, remember there's a -1 in front of that x. So when we go for the slope, it'd be -1 over 1. So again, for part B, we're going to take our 4 inequalities and graph them. So let's start with the x is greater than or equal to 3. Since it's just x, that'd be a Vux problem, so it'd be a vertical line going through the x-axis at 3. Since it's equal to, it's going to be solid, and since it was greater than, I'm going to shade to the right. So here's my graph again, solid, shaded to the right, going through x is equal to 3. Next we have x is less than or equal to 5, so it's going to be another solid line shaded to the left this time since it is less than 5, going through the x-axis at 5. So as you can see here, now our double shaded area would be right in between x equals 5 and x equals 3. Let's keep going. Now we have y is greater than or equal to 2, so that'd be a Hoy problem. So we're going to draw a solid line since it's equal to, going through the y-axis at y equals 2, and we'll shade above it. So now our triple shaded area would be right in here so far. And then finally we have the y is less than or equal to negative 1x plus 9. So the y-intercept is 9, and then we'd have a slope of negative 1 over 1. So I'm going to start up at 9 and go down 1 and over 1. And I'll do a solid line because it was equal to and shade below it since it's less than. So you can see here I'm starting up here at 9 and I went down 1 and over 1. Again, a solid line, and I'm going to shade below it. So now through all of that mess, we see we have a triple shaded area right in here where we had the x's that go right here, the y right here, and now our diagonal line right here. So all through right here would be our quadruple shaded area. So I just went in and heavy-handed that quadruple shaded area, so it really drives home the fact that right here is that quadruple shaded area. So part C, it says you enter a logo 5 inches wide and 6 inches high. Use the graph to determine if it meets the contest requirement. So we're going to basically, if it's 5 inches wide, that's our x value, and 6 inches high is our y value. So we're looking to see is 5, 6 a ordered pair within that quadruple shaded area. So going to our origin, which is right here, let's count over 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, 6. That would be right up here, which is not in that quadruple shaded area. So if you had a logo that was 5 inches wide and 6 inches high, it would be outside of the requirements of the contest and you would be disqualified. That's it for this section. Make sure you jot down anything you didn't understand that we can go over in class, and we'll see you then.